I'm going to be talking to Paolo Bomben, who's the Senior Manager, Clean Technology Development in the Clean Resources Division of Alberta Innovates, about the Carbon Fiber Grand Challenge Phase 2. So welcome to the interview, Paolo.
Thank you, Markham. I'm happy to be here.
Now, I've interviewed you a couple of times about Alberta Innovates work of the research that goes into turning bitumen into carbon fiber. You have this grand challenge. It's already been through phase 1. Now we're into phase 2. What's phase 2 all about?
Phase 2 is about solving the technical challenges that exist for converting bitumen into carbon fiber. And so by the end of phase 2, we hope the teams have a pathway to convert bitumen into carbon fiber consistently, and that the products will be roughly 10 grams of carbon fiber per day and have desired strength and modulus, which is stiffness, properties that end-use customers will want.
So the phase 1, as I understand it, was to spin bitumen into carbon fiber, prove that it could be done. So that was accomplished. Now we're going to, is phase 2 all about, getting to a commercial process?
Not quite. This is sort of the middle innings of a baseball game, if you want a sports analogy. So we're working through all the difficulties and the technical problems that exist, and to get the researchers and teams to a state where then they can enter phase 3, which will follow phase 2. Phase 3 is really about scaling it to a level where it's ready to be commercialized at the end of phase 3. But phase 2 is working out all the kinks and bugs in the process that right now are preventing researchers and teams from producing carbon fiber consistently, which means at the same width, the same properties that customers want.
Now, are they making carbon fiber per se, or is this carbon fiber precursor the material that then goes into the carbon fiber manufacturing process?
The teams will be making carbon fiber by the end of phase 2. However, you bring up a very good point. The input to the process also needs to be researched as well and developed. It's very important to have the right input bitumen material to get the right properties of carbon fiber out the other end. So if you don't have a good input, you're not going to get a good output. So that's an also critical component of phase 2. The researchers need to actually modify the bitumen a little bit to make it suitable to make carbon fiber.
Now, you've got 12 teams competing for $5.27 million. And I've interviewed a couple of the teams, and these are teams from all over the world. Some of them are Canadian, there's Australian, American, and so on. And so I interviewed a couple of the Canadian teams, and they said, you know what, yes, there are technical problems, but we're confident that the research that we're undertaking will solve these problems. So are you fairly confident now? Is Alberta Innovates confident that there will in fact be a commercial ready process at the end of this challenge?
Markham, I believe that we will achieve that by the end of this process. We have structured the process in such a way to sort of move the researchers up the difficulty level through each phase. There are some brilliant minds working on solving this problem, very technically capable. And I believe that by the end of phase 2, we'll set ourselves up really well for these teams to fully solve the problem by the end of phase 3 and have a process that should be ready to commercialize.
So the phase 2 completes in early 2023, right?
That's correct.
When will phase 3 end?
Phase 3 right now, we're targeting the end of 2024 for a completion date for that phase.
And what comes after phase 4 or phase 3, sorry?
So by the end of phase 3, the teams should have a process design, a pathway that would lead to either a pilot facility or straight to commercialization. Our plan is to involve different parts of the value chain, financiers, end users, bitumen producers in phase 3 and bring them together to work with the teams so that there is a pathway at the end of phase 3 to take that all the way to a commercial state and have end users ready to accept the product right away.
Now, I know there have been some fairly big companies involved in this. As I recall, Suncor has been a supporter of the Bitumen Beyond Combustion program. And I know that Zoltec Manufacturing out of Missouri, their carbon fiber manufacturer, they're watching this very carefully. They're interested in setting up a plant in Alberta. Who else, what other kinds of corporate and other partners are coming to the table who might support the commercialization of this process?
So as I mentioned earlier, we have interest from the finance community. So we regularly receive inquiries from venture capital funds and different financiers on the state of progress for carbon fiber. They're watching this very closely and they're ready to get more involved as we move further along. We've had tremendous support within the oil sands industry in terms of the production of the materials required to, the input materials for the carbon fiber process. And now we're starting to really work with potential end users. So we're having conversations with companies in the concrete space, as well as in the automotive sector, about the potential to test out this carbon fiber once we can make enough quantity of it, to make the types of prototypes that they're looking for. So it's starting to come together. It's a work in progress, but we're making advancements every month in the connections and building that value chain that will ultimately lead us to success.
Now, when I think of carbon fiber, the first market for this that occurred to me, of course, was the automotive industry, because they're looking to lighten up electric vehicles that are which are heavier because of the batteries. So that seems like an obvious market for this. But there are some other ones that we wouldn't normally think about, right? I mean, like concrete, using carbon fiber added into the concrete to increase the strength of it.
That's correct. Carbon fiber in concrete can add strength. It also adds durability. Right now, we put steel rebar into concrete and steel rusts. Carbon fiber is non-corrosive, so sorry, it will not corrode. So you won't have the same corrosion issues you have with steel. Another industry could be the rail industry, lightweighting locomotives, as well as making potentially the tracks more durable instead of just making them with steel. So there are different types of potential applications that, if we can bring the cost down far enough, Markham, we would really open up the, potential uses. And again, that would really be beneficial because it would allow us to transform more bitumen into carbon fiber at the end of the day.
Well, Paolo, thank you very much for the insights, and I guess good luck to the 12 teams that are participating in the challenge.
Thank you, Markham, for the opportunity to share the Carbon Fiber Grand Challenge with your audience. I appreciate it.